maybe something slightly different with Fighting Back here has a question. Thank you so much. Question for John. How does the flood model explain the large amount of limestone, most of which is marine in nature? Doesn't limestone require warm, calm waters to deposit?
Okay, you're looking at a word limestone, which simply means stone, as in hard stuff. It's an old Roman word, stone, steen, stein. They're all the same word, they just mean hard. And it's a limey color, right? And we call it limestone because it was found that if you cooked it and you turned it into powder, you could glue things together. And the old stonemasons who came across from Holland and Germany, lim was their old word for glue. So this was the glue stone, right? So that's the meaning of the word stone. Now, the common ingredients are calcium and carbonate, a little bit of water, etc., a few other things, minor silica, etc., most of which is marine in nature. You may be absolutely flabbergasted if you actually go out there and try to prove that. It's in the textbooks, but you'll find that if you ask, how do I prove this is marine in nature? The answer is you have to find some marine fossils. And you'll be staggered by the fact that a huge amount of limestone is actually chemical, not marine, right? Now, you've got the next bit. Doesn't limestone require warm, calm waters to deposit? Well, our standard story says yes to that. But in reality, we get limestone flowing as sheets out of volcanic eruptions. You will find that limestone is a chemical as well as something that is a chemical used by shells that will then make themselves. And so you can end up with mega beds of shells that turn into limestone. Perhaps I'll explain. In our present world, we have a few sub-turbulent, sub-catastrophic events like underwater earthquakes. So you'll come off the coast. There's one thing I'm thinking of right at the moment. On the north coast of New Zealand, you have massive volcanic eruptions that have occurred, and the whole land has been lifted up. The local native story is there was a big flood covering the world, and then the local god hauled up the land in steps, right? And it sort of matches the evidence there, and it does include a reference to the flood. But in reality, at this site, you've had plenty of evidence that marine creatures from 2,000 meters below are mixed with shells from the seashore, because I've found them myself. You know, the nice sort of scallop shells you find over here, mixed with tiny little protista sort of things with calcareous shells, all together, and the siliceous protista as well. And so you know you've had a flow that's come from one place, moved down, and collected everything as road, and now it's deposited as a very lime-rich bed. Now, even that sort of scale thing doesn't match any of the limestone beds that we find in the geological record. So let's go back to one of the questions where we talked about the size of these beds, and I mentioned the limestone that we filmed in Wales. You can start with me on that limestone. We'll go to Alabama. We'll go to Newcastle, Alabama, right? You can go for, check my WhatsApp. Are you talking to me there, George?
Oh, no. Sorry, Dr. Mackay.
Okay. You will find that if you start in the limestone beds in portions of Alabama, you can then follow them all the way through, up through Tennessee, up through Kentucky, right up through Pennsylvania, because I have walked an immense amount of them, right, collecting fossils. And then you can flip over into Canada, and you can exit at Nova Scotia. And remember, we found those fossil thorns. That was Nova Scotia, and the limestone is not far away. And then you can find it over on the islands in between. You can end up in England. And if you stood on the west coast of England, as we did for one documentary, you can say, if I was in a Doctor Who phone box, I'd swear I was in the same place on the other side. Hence your idea of continental separation, etc. Then you can follow them all the way through, and you can fly like I have from England all the way along the Mediterranean, photographing the limestone, all the way down through Jerusalem, and you can see, well, there's even limestone there with fossil snakes with legs in it, right? So if you think limestone has to be marine, I'm sorry, leg snakes don't feature much in marine environments. So you've got all of this, much of which has got shells in, but you'll be staggered by the amount of chemical limestone that's actually out there that just comes out of volcanic rocks. It's soluble and it will reprecipitate. So the person who asked the question need to go back and check how much are you actually asking about, because the bigger problem is where did all the chemical stuff come from, not just where did all the shells come from. The shell beds are enormous and they're mixed. Remember the stuff I told you about in New Zealand? You have low depth stuff mixed with unbelievably deep stuff. Right. So again, you end up as catastrophic. You guys in Canada, if you go up by the lakes, I've walked all of those limestone beds up by the lakes, and you will find gigantic big nautiloids, pointed nautiloids, and you can map the trilobites with them. They all came in the same direction. There is crinoids, right? So I flipped off my photographs to one of the world experts on trilobites and a world expert on crinoids, and they said, hey guys, we've got these two things together. And they said, shouldn't be. I mean, you've got crinoids still off the coast of North America at 150 meters below the sea level. And yet your other creatures that are there, your clam shells and your mussel shells, are all shallow creatures because there's worms in it as well. And so this is a mixed environment. So your limestone there has come from a catastrophic dump on a mega scale, right? So I think we've probably covered just about everything there.
Yeah, the other point, John, is secular explanations about the formation of limestone suggest that they form at 1 to 2 centimeters per 1,000 years. Now we found many fossils that are buried in the limestone. I mean, how can that creature that's died remain there for thousands of years waiting for it to be buried? I mean, there are videos of whale carcasses at the base of the ocean where they've come back 2 years later. Everything, including the bones, have been eaten away. So this silly notion that it takes 1 to 2 centimeters per 1,000 years is ridiculous.
Well, it's got in reverse, not by observation. The observations are what you've said, right? If you then, on the other hand, say, well, Charles Darwin said the dinosaur rocks were 300 million years old. We've changed that a bit now. They're 200 million years old. But you start at the top of the rocks in Alberta and you go down and you say, well, it's 13, 14, 15,000 feet, 5,000 meters to the granite. Now, all of that had to take at least 400 million years to form. Divide the 4,000 meters by that figure and you end up with how much rock had to be laid down at each year. Now, if that's the way you do it, you then say, well, look, I've got this belemnite. If you have Joseph Hubbard on your program, I'd encourage you to do that. He will show you some of the papers he's done in which we take this long, thin backbone, really, of a squid, and it's standing up through tens of thousands of years of sediment. It can't do that, right? It's a limestone structure. It will dissolve under depth in water, and yet here it is standing up. I know because I actually found it. So you will find that stuff is really, really impressive. And it's found by having the false assumption. We can start by assuming the millions of years are real and working backwards. If you start by the observation you mentioned, George, you'll end up saying this is nonsense.
Yeah. Standing?
Yeah, no, that's I'm soaking it all in. So much good information here. This is really rewatchable. Now that